Hey! Alright, in this problem, we're dealing with this character who takes off from the airport and goes flying. So the airport, we're told, is 4 miles west and 3 miles south of the city center. And we're told that when they take off in this plane, they are a total of, they're 7 miles, for every 8 minutes. After 8 minutes, they are 7 miles east and 10 miles north of where they started. So for every 8 minutes of travel, 7 miles east, 10 miles north. So I've kind of plotted here. After 8 minutes, they're at the point 37. 8 more minutes, they're at the point 1017, or 10 miles east, 17 miles north. After another 8 minutes, they're 17 miles east, 27 miles north. And we're told that at 90 minutes, an hour and a half later, so at 2:30, I'm going to put that onto our table here, at 90 minutes, kind of crunched myself in here a little bit. Okay. They fly over a nearby town, and we want to know what time was it when they flew over this nearby town. So what I'm going to start by doing is just kind of filling out a table like we've done before. This is, again, it's kind of a parametric equations problem, and we are going to actually write the equation in this one. So we're just going to figure out where they are at all these positions, and I already figured out the first few. They're at 3 miles east, 7 miles north. After 16 minutes, they're 10 miles east, 17 miles north, and at 24 minutes, they are 17 miles east and 27 miles north. So I'm going to kind of work down and fill out the rest of this table. But I'll do that by myself because it's kind of boring. So just give me a second. Okay, so I filled out the rest of the table. And we get down to 88 minutes. She is 73 miles east and 107 miles north. Then we got 90, and 90 is a problem because 90 is not a multiple of 8. So we can't just go to the next number in the table. By the way, on the problem I've asked you to solve, it's not quite this complicated. But you'll be following roughly the same steps, but not quite as complicated. So we need to figure out where she is at the 90 miles. Well, I think the easiest way to do this will be to come up with some sort of an equation that outputs our east position, that's our x, and our north position, that's our y, based on our time t. And we've done this before. Parametric equation. So first we're going to take a look at what is our change in our output variable. And this is going to be a plus 7, but we expected that because she's 7 miles east for every 8 minutes. And our change here in time is 8. So this is technically what is the slope, I guess, but the rate of change of our eastward movement, our eastward position with respect to time is 7 over 8. And so our rule, I'll write this up here, our x, which is our east position, is equal to 7/8 x. And then we do have to adjust because this rule is going to give us bum outputs because we aren't starting at 0, 0, we're starting at -4. So when I plug in 0, I should output -4. And right now, if I plug in 0, I output 0. So I have to just add a -4 in there. And that gives us our eastward position when I plug in x minutes. And the same with y. From -3 to 7 is plus 10. So it's 10 for every 8. So let's just put our east position. And by the way, I shouldn't put x here, I should put t. We want to specify, because this is going to matter later, which matters now, the time is in minutes. T minutes. Okay. And our y position, our north position, is our formula is we would go 10 miles north for every 8 miles, for every 8 minutes. So 10 for 8, 10 to 8 is 10 over 8, and that reduces to 5 over 4. So our y position is 5 over 4t. And then this rule, of course, won't work because if we input a 0, right now it's going to output a 0, but we want to output a negative 3. So the rule has to be adjusted by putting that negative 3 there. And this is, of course, t in minutes. So now all I have to do is just plug in 90 minutes to get the position of the second town, the location where she's at the 90 minutes. So if I put in x, let's put position at t equals 90. So x equals 7/8 times 90 minutes minus 4, and our y position will equal 5/4 times 90 minus 3. And let's just put my calculator out and do that. So let's go 7 ABC 8 times 90 minus 4 gives us 74 3/4. Let's see. That's x equals 74 3/4, which I'm also going to put down second ABC, enter, that's 299/4. And the reason why I'm doing both a mixed number and an improper fraction is because the improper fraction is typically easier to deal with if you have to put it into another equation. Mathematically, it's easier to work with improper fractions, but mixed numbers are usually easier to understand. 74 3/4 kind of makes more sense. I can kind of guess where that is on the number line, have a rough idea. Whereas 299/4, I'm not sure where that is on the number line. Is that bigger or smaller than some other given number? I don't know. So it's more complicated or difficult to understand, but easier to work with mathematically. Okay, so the second one, we'd have 5ABC4 times 90 minutes minus 3 gives us 109.5. Y is 109.5, which I'll also turn into a mixed number or improper fraction, 219/2. Okay, and this is miles east, miles north. Oh yes, by the way, this is from start. That's where the airport is. What if I want to know where they are in relation to the city center? Okay, so let's put position relative to city center. Well, if we go back here and look at where the city center is, the city center is 4 miles to the east, and it's 3 miles north. So we just need to take 4 miles off of our east distance and 3 miles off of our north distance. So wherever I'm at, I'm actually 4 miles closer in the east direction, in the x direction, and 3 miles closer in the north direction. So that's pretty easy to do. So we'll call this x sub c for city center equals 74 3/4 minus 4, which is 69 3/4. Yeah. So I guess I lied. That's a little easier to deal with mathematically than 299/4. Let's see. So then for the north direction, we'll just call it y sub c for, or It's actually probably not the best way. I should call it change in y and change in x, perhaps. Yeah. Would be 109 and 1/2 minus 3, because we started 3 miles closer. So that's 106 and 1/2 miles north. And this is miles east. Okay. So we have one other thing to do. Okay, so the last thing I want to do is our two equations up here are, you know what? Let's review what we've done so far. First, we were told that she leaves the airport and then she goes on this flight, and at an hour and a half or 90 minutes later, she is over some nearby town. And the question is, how far away east and north, what's the position of the nearby town? All right, we'll pause that. And we want that position in relation to this city center, which is actually a little bit off from the airport. So first of all, we came up with this table, time, and then for our east and north position at that time, and the east and north position are just our x and y coordinates. So we said 0, we're at -4, -3, that's the position of the airport at time 0 when she leaves. 8 minutes later, she's at 3:07. 16 minutes later, she's at 10:17, and so on. And we wanted to work down and find out, well, what's her position at 90 minutes? Well, since 90 wasn't a nice multiple of 8, which, hint, hint, in your problem, it's going to work out better than this. What we need to do is come up with some sort of a rule that would output our east and north position based on our time. And then we just plug that number into the rule and get it. Which, by the way, we did. It was 74 3/4 and 109 and 1/2, which kind of makes sense because it's only 2 minutes from 88 to 90 and just a little bit extra distance on each part. So we need to come up with that rule. To find the rule, we looked up here and we said, okay, the rate of change of the east position is 7 units for every 8 minutes, so that's 7/8. So our rule is x equals 7/8 t, and then we had to add in the -4 to account for the starting position. For the northward movement, our difference is 10 units, 10 miles for every 8 minutes. So it was 10/8, which we reduced to 5/4. Okay, 5/4 t, and then -3 to adjust for the initial position. And then we just plug in our 90 minutes into those two rules, and we output a east and north position for the airplane at that time. Then we want to figure out, well, in relation to the city center, so to make up for that, we had to just take our eastward position and take away 4 miles, and our north position and take away 3, and that just accounts for the fact that we're actually 4 miles eastwise closer to the city center than we are from the airport at any location out here in the same, or any location on the line. So I was a little bit closer, both east and north, so we had to take off some miles for that. Finally, we do want to have our equations here. We want to rewrite our equations so that it's just in miles per hour instead of minutes, instead of miles per minute. Okay? But that's relatively easy to do. Okay, so we're going to change our rates to miles per hour. So our eastward rate was 7/8, so that's 7 miles per 8 minutes. We're just going to convert that by writing 60 minutes over 1 hour. So then we just have to, minutes will cancel with minutes, and we'll be left with miles per hour. So 7 times 60, 7 times 60 is 420. 420 miles per hour in the eastward direction. Wow, that is really fast. didn't really consider how fast this airplane would be going when I made up this problem. For north, we had 5 miles for every 4 minutes. So we want to figure out, oh, wait a minute. It's not 4 and 20. I knew something was wrong. Yes, that's 420 per 8 times 1 is 8 for 8 hours. So 420 divided by 8. Let's see, 420, that's not going to be divisible by 8. So ABC 8 gives us 52.5, which is 105 over 2. So that's 105 over 2 miles per hour. Knew something was wrong here. So down here, we're going to multiply this by the same conversion factor. 60 minutes over 1 hour. So 5 times 60 is 300 over 4 miles per 4 hours. And then that will be divisible. 300 divided by 4 gives us 75. So that is 75 miles per hour. So I can now rewrite my 2 equations. So the east equation, I'm running out of space here to put these things. It's not going to be easy to read later. Let's put east equation will now be x equals, and instead of, our original equation was 7/8 t minus 4, because 7/8 was our rate. So now it's going to be 102, or 5, sorry, over 2t, and it still needs to be minus 4, because we still have to adjust our rule for the fact that we started 4 miles, 4 miles back. And our north equation will be y equals 75t, and then we still have our minus 3 to adjust for that. Miles being, we're starting back a little bit. And finally, t is in hours. Okay. So again, all we had to do is take our 2 rates and convert them from miles per minute into miles per hour by using the conversion factor, 60 minutes to 1 hour. Don't forget to multiply the denominator together like I almost did. And that gave us a miles per hour rate. And then we just substitute that rate into our 2 equations to replace our miles per minute rate. There we go.